Alright, so far we've looked at solving inequalities. Now, the real life situation where we need some modification is to convey ideas such as between so and so, or less than this but more than that. So sometimes we want to be able to model situations where things are not so straightforward. For example, let's say I want my solution to be this, meaning I want my solution to be between 1 and 6. So one way to say that would be I want x to be greater than 1 and I want x to be less than 6. Or in a more non-mathematical language, maybe you would use but. You'd say x is greater than 1 but it's also less than 6. Yeah. However, the use of the word also is similar to using the word and. Whereas in the second case, you would say x is less than 1 or x is greater than 6. So these kind of situations are called compound situations, or expressed through compound inequalities. What a compound inequality is basically two inequalities stated together. Two inequalities stated together. For example, in a shorthand way, it can be stated this way. Now, this typically consists of two inequalities. The part where it says the first two terms and the part where it's the second two terms. Okay, so this says, so I just go ahead and solve it using my usual means, just being careful that when I divide by negative, the sign flips. So I get x is less than 3 from here, and from here, once again, division by negative number flips the sign, greater than equal to negative 2. Okay, so this says I want this thing to be between negative 5 and 5, and that happens so long as x is less than 3 and x is greater than equal to negative 2. Okay, so x is negative 2 or larger but less than 3, which means that x can be in this particular interval on the number line. Solid on negative 2 because it can be negative 2, and hollow on 3 because it cannot be 3. Okay, so these basically you have to be aware of these two connectors called and or. Okay, and the use of and or in math is sometimes slightly different from how we use it in the language sense. For example, if a shop says there's a 15% discount if you shop for $20 on a Friday, typically it means that you have to shop for $20 and you have to shop on a Friday. So if you shop for $20 on a Wednesday, then in the and situation, you don't, right? So in the and situation, you don't get a discount because it's not a Friday. But in the or situation, says 15% discount if you shop for $20 or if you shop on a Friday. So it satisfies the $20 situation, means you get the discount. In the same way, if you have $15 on Friday, do you get a discount? In the and situation, that is still a no, because it has to be Friday and it has to be $20. And in the or situation, it's still a yes, because it's either $20 or it's a Friday. So basically, for and you need both conditions to be satisfied, and for or you need just one of them to be satisfied. It doesn't matter which one. Okay, let's look at two and examples and two or examples to clarify. So I add 5, I get 4x is greater than 12, divide by 4. So I need x is more than 3 and whatever I get here, which is 5x is less than 5 and x is less than 1. So this has to be connected with an AND. So that means x is 3 and greater and 1 and lesser. So there is no solution. And there is no solution because that's not possible. It's not possible for a number to be less than 1 and greater than 3 at the same time. Okay. This is add 7. So you get 2x is greater than 10, x is greater than 5. Add 4, 5x is less than 10 and x is less than 2. So again, you need an AND. So you need a number that's larger than 5 and less than 2 at the same time, which also gives you a no solution because you cannot be greater than 5 and less than 2 at the same time. Okay, so that means there is no solution. So let's see, when is there a solution? When would there be a solution? So one of them would be, for example, x less than 4 and x greater than -1, because that would mean it's between -1 and 4. Or if it said x less than 7 and x less than 3, because that would mean as long as it's less than 3, it's going to satisfy both the conditions. Okay. Now let's look at an OR example. In the OR example, I add 5, I get 3x is less than equal to 18, I divide by 3, x is less than equal to 3. I subtract 2, 5x is greater than -5, divide by 5, and x is greater than -1. But this is an OR situation. So it's saying either it's more than -1 or it's less than 3. So let's really think about it. Greater than -1 gives me all of this, and less than equal to 3 gives me all of that. But it's an OR situation, which means where is it? At least some part of it is red, and that is everywhere. Which means the solution is all values of x. Okay. So in OR situations, you may end up with something like this, which means no matter what x you pick, one of these two things is going to be true. Let's look at the second example with an OR. Add 3, 2x less than 10, divide 2, x less than 5. Say add 4x, subtract 3, divide 4. So you need x less than 5 or x greater than equal to 8. So again, it's either 5 or less or 8 and greater. Now in this case, it's slightly different because it's 5 or less and 8 or above. So OR means it's either in this red region or in this red region. Okay. So here we're going to introduce a new notation. When you have to write this as an interval, right, this is going to be -infinity to 5, and we use union 8 to infinity. This union is used to connect disconnected parts of the number line. And these symbols just mean negative infinity and infinity. Negative infinity and infinity. And we use these kind of brackets to indicate that the point is not included. Point not included, which is the same as hollow dots. And we use square brackets to indicate that the point is included, which is the same as saying solid dots. So sometimes we also use a combination, right? This would mean this point is included and this point is not included. And in the case of OR, sometimes we may have these disconnected regions. To represent them, we use this symbol called union, which for our purposes, you can think of it as just saying OR. So this says X is in this left interval or it's in the right interval. With this, so now that we know how to work with compound functions, how they're connected by OR and, next goal is to understand an application of it, which is called absolute value of a function. And this absolute value is actually understood in terms of a compound inequality, so that's why we had to introduce that first. Okay, that's it for this video. We're gonna look at absolute values in the next video.